History of the Spring Framework. The Spring Framework is an open source framework that has multiple versions released, with the latest one being 5. Spring Framework 1. This version was released on March 2004 and was covered the following functionalities. Spring Core. This is a lightweight container with various setter and constructor injection. Spring AOP. This is an aspect-oriented programming interception framework integrated with the core container. Spring Contexts. This is an application context concept to provide resource loading. Spring DAO. This is a generic DAO support that provides access to a generic data exception hierarchy with any data access strategy. Spring GDBC. This is a GDBC abstraction shortened error and resource handling. Spring ORM. This is a Hibernate support session factory management. Spring Web. This Web MVC framework integrates various Vue technologies. The Spring Framework 2 was released in October 2006 and Spring 2.5 was released in November 2007. The Spring Framework 2 release was based around two themes: simplicity and power. This provides you with the following features: improvements in the IOC container and AOP, including the AspectJ annotation, support for AOP development, introduction of Beam configuration dialects, XML-based configuration is reduced and XML schema support and custom namespace is introduced, annotation-driven configuration that requires component scanning to auto-detect annotated components in the class path using annotations such as component or specialized annotations such as repository, service, and controller. Introduces annotations such as request mapping, request param, and model attribute for MVC controller. Spring Framework 3. This version was released in December 2009. This provides you with the following features: supports REST in Spring MVC, task scheduling and asynchronous method execution with annotation support, cache abstraction, bin definition files, environment abstraction. Supports Java 7 features. Spring Framework 4. This provides you with the following features: supports external bin configuration using a Groovy DSL, added lightweight messaging and WebSocket-style architectures. Auto-wiring is based on generic types, supports Java 8 features. Latest version of Spring Framework 5 provides you with the following features: supports reactive processing. Reactive processing is a paradigm that enables developers build non-blocking asynchronous applications that can handle back pressure, flow control. Support Kotlin, supports Java 9 features. The Spring Framework consists of features organized into about 20 modules. These modules are grouped into core container, data access integration, web, AOP, instrumentation, messaging, and test, as shown in the following diagram. The core container consists of the Spring Core, Spring Beans, Spring Context support, and Spring Expression modules. The Spring Core and Spring Beans modules provide the fundamental parts of the framework, including the IOC and dependency injection features. The Bean Factory is a sophisticated implementation of the factory pattern. It removes the need for programmatic singletons and allows you to decouple the configuration and specification of dependencies from your actual program logic. The Context module builds on the solid base provided by the Core and Beans modules. It means to access objects in a framework-style manner that is similar to a GMDI registry. The application context interface is the focal point of the Context module. Spring Context Support provides support for integrating common third-party libraries into Spring application context. The Spring Expression module provides a powerful expression language for querying and manipulating an object graph at runtime. The Spring AOP module provides an AOP Alliance-compliant aspect-oriented programming implementation, allowing you to define, for example, method interceptors and point cuts to cleanly decouple code that implements functionality that should be separated. The Separate Spring Aspects module provides integration with AspectJ. The Spring Instrument module provides class instrumentation support and class loader implementations to be used in certain application servers. The data access integration layer consists of JDBC, ORM, OXM, GMS, and transaction modules. The Spring JDBC module provides a JDBC abstraction layer that removes the need to do tedious JDBC coding and parsing of database vendor-specific error codes. The Spring TX module supports programmatic and declarative transaction management for classes that implement special interface for all your POJOs, plain old Java objects. The Spring ORM module provides integration layers for popular object relation mapping APIs, including GPA and Hibernate. The Spring OXM module provides an abstraction layer that supports object XML mapping implementations. The Spring GMS module contains features for producing and consuming messages. The web layer consists of the Spring Web MVC, and Spring Web Socket module. The Spring Web module provides basic web-oriented integration features, such as multi-part file upload functionality and the initialization of the IOC container using servlet listeners, and a web-oriented application context. It also contains an HTTP client and the web-related parts of Spring's remote support. The Spring Web MVC module contains Spring's module view controller and RESTful Web Services implementation for web applications. Benefits of the Spring framework. Spring makes programming Java quicker, easier, and safer for everybody. Spring's focus on speed, simplicity, and productivity has made it the world's most popular Java framework. Spring is flexible. Spring's flexible and comprehensive set of extensions and third-party libraries let developers build almost any application imaginable. At its core, Spring Framework's inversion of control and dependency injection features provide the foundation for a wide-ranging set of features and functionality. Whether you are building secure, reactive, cloud-based microservices for a web or complex streaming data flows for the enterprise, Spring has the tools to help. Spring is productive. Spring Boot transforms how you approach Java programming tests, radically streamline your experience. Spring Boot combines necessities such as an application context and an auto-configured embedded web server to make microservice development a cinch. To go even faster, you can combine Spring Boot with Spring Cloud's rich set of supporting libraries, servers, patterns, and templates to safely deploy entire microservices-based architectures into the cloud in record time. Spring is fast. Framework engineers care deeply about performance. With Spring, you'll notice fast startup, fast shutdown, and optimized execution by default. Increasingly, Spring projects also support the reactive programming model for even greater efficiency. Developer productivity is Spring's superpower. Spring Boot helps developers build applications with ease and with far less toil than other competing paradigms. Embedded web servers, auto-configuration, and fetch jars help you get started quickly, and innovations like leave reload in Spring DevTools mean developers can iterate faster than ever before. You can even start a new Spring project in seconds with a Spring initializer at start.spring.io. Spring is secure. Spring has a proven track record of dealing with security issues quickly and responsibly. The Spring committers work with security professionals to patch and test any reported vulnerabilities. Third-party dependencies are also monitored closely, and regular updates are issued to help keep your data and application as safe as possible. In addition, Spring Security makes it easier for you to integrate with industry-standard security schemes and deliver trustworthy solutions that are secure by default. Spring is supportive. The Spring community is enormous, global, diverse, and spans folks of all ages and capabilities, from complete beginners to seasoned pros. No matter where you are on your journey, you can find the support and resources you need to get you to the next level. quick starts, guides and tutorials, videos, meetups, support, or even formal training and certification. The Spring Framework application area. Spring's flexible libraries are trusted by developers all over the world. Spring delivers delightful experiences to millions of end users every day, whether they're streaming TV, connected cars, online shopping, or countless other innovative solutions. Spring also has contributions from all the big names in tech, including Alibaba, Amazon, Google, Microsoft, and more. In this course, we will use IntelliJ IDEA to write code. IntelliJ IDEA is one of the best IDEs used by most software developers. According to 2019 statistics from JetBrains, 65% of Java developers choose IntelliJ IDEA. IntelliJ IDEA is very customizable, very fast. It has a lot of features for boosting your productivity. IDE analyzes your code looking for connections between symbols across all project files and languages. Using this information, it provides in-depth coding assistance, quick navigations, clever error analysis, and of course, refactorings. Every aspect of IntelliJ IDEA is designed with ergonomics in mind. IntelliJ IDEA is built on a principle that every minute a good developer spent in the flow is a good minute, and things that break developers out of that flow are bad and should be avoided. Mission-critical tools such as integrated version control systems and a wide variety of supported languages and frameworks are all to hand, no plugin hassle included. In this video, we'll create a simple web application using Spring Boot 2. Let's run the IntelliJ and on the start screen, select Create a new project. For all Spring applications, you should start with the Spring Initializer. The initializer offers a fast way to pull in all the dependencies you need for an application and does a lot of the setup for you. As a status service URL, we will use default start.spring.io. We will call our project Simple Web Application. In this example, we will use only one dependency, Spring Web. Next, select the version of the Spring Boot. We will be using version 2.3. So the Spring application has been downloaded, and in the side panel we can see our initial project. Let's get down to writing some code. In the com.example.simpleWebApplication package, let's add REST controller and name it Simple Controller. Add a method to the REST controller and we'll return the hello world string. Let's talk about Spring Beans in other video. The class is flagged as a REST controller, meaning it's ready for use by Spring MVC to handle web requests. Request mapping maps route and point to the index method, when invoked from a browser or by using curl on the command line. The method returns pure text. That's because the REST controller combines controller and response barring, two annotations that results in web requests returning data rather than a view. The Spring Initializer creates a simple application class for you. However, in this case, it's too simple. We need to modify the application class. Spring Boot application is a convenience annotation that adds all of the following. Configuration. Takes the class as a source of bin definitions for an application context. Enable auto-configuration. Tell Spring Boot to start adding beans based on class path settings, other beans, and various property settings. For example, if Spring Web MVC is on the class path, this annotation flags the application as a web application and activates key behaviors, such as setting up a dispatcher servlet. The component scan. Tell Spring to look for other components, configurations, and services in the COM example package, letting it find the controllers. The main methods use Spring's Boot Spring application run method to launch an application. Did you notice that there wasn't a single line of XML? There is no web XML file either. This web application is 100% pure Java, and you didn't have to deal with configuring any plumbing or infrastructure. There is also a command line runner method marked as a bean, and this runs on startup. It retrieves all the beans that were created by your application, or that were automatically added by Spring Boot. It sorts them and prints them out. To run the application, just click Run Simple Web Application button. You should see org.springframework.boot.autoconfigure beans. Now run the service with curl in a separate terminal window by running the following command, or just open following link in your web browser. To connect your project to the repository, you need to follow several steps. First, create a new repository on GitHub. To avoid errors, don't initialize the new repository with readme, license, or gitignore files. You can add these files after your project has been pushed to GitHub. Further, if you don't already have a CCH key, you must generate a new key. If you are unsure where you already have a CCH key, check for exciting keys. If you don't want to re-enter your passphrase every time you use your CCH key, you can add your key to the CCH agent, which manages your CCH keys and remembers your passphrase, adding a new CCH key to your GitHub account. IntelliJ IDEA allows you to quickly enable your project's integration with a version control system and associate it with the project root. Choose Enable Version Control Integration from the VCS operation pop-up from the main VCS menu. In the Enable Version Control Integration dialog that opens, select Git. After VCS integration is enabled, IntelliJ IDEA will ask you where you want to share project settings file via VCS. You can choose Always Add to synchronize project settings with other repository users who work with the IntelliJ IDEA. Open the Version Control tool window, Alt+9, and switch to the Local Changes tab. Put any files in the Unversioned Files change list under Version Control by selecting Added to VCS from the context menu. You can either add the entire change list or select separate files. Select the files you want to commit or an entire change list in the Local Changes view and click Commit button on the toolbar. The Commit Changes dialog that opens lists all files that have been modified since the last commit, as well as all newly added unversioned files. Review the list of files you are about to commit and clear the checkboxes next to the files and directories that you don't want to include in the commit. Changes in the excluded files will remain in the active change list and you can commit them later. You can also select files under the Unversioned Files node. IntelliJ IDEA will stage and commit these files in one step. Enter a commit message. When you are ready, click Commit. Invoke the push dialog, then you are ready to push your commits by selecting VCS, Git, Push from the main menu. If you haven't added any remotes so far, the Define Remote link will appear instead of a remote name. click it to add a remote. In the dialog that opens, specify the remote name and the URL of your repository on GitHub and click OK. Then just click the Push button. I propose to consolidate gained knowledge. Presently, the Spring Framework 5 is the most popular Java framework for enterprise application development, providing a well-thought-out programming and configuration model. Knowledge of Spring is one of the most common requirements for a Java developer position. Spring's flexible libraries are trusted by developers all over the world. Spring delivers delightful experiences to millions of end users every day, whether they're streaming TV, connected cars, online shopping, or countless other innovative solutions. Spring also has contributions from all the big names in tech, including Alibaba, Amazon, Google, Microsoft, and more. Spring is huge. In fact, this is a whole container of frameworks that allow you to perform tasks of any complexity, from working with database to testing procedures. The Spring Framework 5 consists of features organized into about 20 modules. These modules are grouped into core container, data access integration, web, AOP, instrumentation, messaging, and tests, as shown in the following diagram. It's proposed to use IntelliJ IDEA for training in the current course. IntelliJ IDEA is an integrated development environment written in Java for developing computer software. According to 2019 statistics from JetBrains, 65% of Java developers choose IntelliJ IDEA. IntelliJ IDEA making development an enjoyable experience. Every aspect of IntelliJ IDEA has been designed to maximize developer productivity. Together, intelligent coding assistance and ergonomic design make development not only productive but also enjoyable. For all Spring applications, you should start with the Spring Initializer. The Initializer offers a fast way to pull in all the dependencies you need for an application and does a lot of the setup for you. IntelliJ IDEA allows you to quickly enable your project's integration with a version control system. It's proposed to use Git for current course. Git is a free and open-source distributed version control system designed to handle everything from small to very large projects with speed and efficiency. In this video, we will talk about the concept of inversion of control. So, what is it? Inversion of control is a principle in software engineering by which the control of objects or portions of the program is transferred to a container or framework. It's most often used in the context of object-oriented programming. By contrast with traditional programming, in which your custom code makes calls to a library, inversion of control enables a framework to take control of the flow of the program and makes calls to your custom code. To enable this, frameworks use abstractions with additional behavior built in. The advantages of the inversion of control are decoupling the execution of the task from its implementation, making it easier to switch between different implementations, greater modularity of the program, greater ease in testing a program by isolating a component or mocking its dependencies, and allowing components to communicate through contracts. In general, inversion of control can be decomposed into two subtypes: dependency injection and dependency lookup. These subtypes are further decomposed into concrete implementations of the inversion of control services. Dependency lookup is a much more traditional approach, and it comes in two types: dependency pool and contextualized dependency lookup. To a Java developer, dependency pool is the most familiar type of inversion of control. In dependency pool, dependencies are pulled from a registry as required. Spring also offers dependency pool is a mechanism for retrieving the components that the framework manages. Contextualized dependency lookup is similar in some respects to dependency pool, but in contextualized dependency lookup is performed against the container that is managing the resource not from some central registry, and it's usually performed at some set point. Dependency injection, although it appears counterintuitive at first, is actually much more flexible and usable than dependency lookup. It also has two common flavors, constructor and setter dependency injection. Constructor dependency injection occurs when a component's dependencies are provided to it in its constructor. The component declares a constructor or a set of constructors, taking as arguments its dependencies, and the inversion of control container passes the dependencies to the component when instantiation occurs. In setter dependency injection, the inversion of control container injects a component's dependencies via Java bean-style setter methods. Component setters expose the dependencies the inversion of control container can manage. In case of field-based dependency injection, we can inject the dependencies by marking them with an auto-wired annotation. The core of Spring's implementation is based on dependency injection, although dependency lookup features are provided as well. When Spring provides collaborators to a dependent object automatically, it does so using dependency injection. In a Spring-based application, it's always preferable to use dependency injection to pass collaborators to dependent objects, rather than have the dependent objects obtain the collaborators via lookup. Although dependency injection is the preferred mechanism for wiring together collaborators and dependent objects, you need dependency lookup to access the dependent objects. Spring cannot automatically wire up all of your application components by using dependency injection, and you must use dependency lookup to access the initial set of components. In the Spring framework, the inversion of control container is represented by the interface application context. The Spring container is responsible for instantiating, configuring, and assembling objects known as beans, as well as managing their life cycle. The Spring framework provides several implementations of the application context interface, class path XML application context, and file system XML application context for standalone applications, and web application context for web applications. In order to assemble beans, the container uses configuration metadata, which can be in the form of XML configuration or annotations. In this video, we will talk about beans in more detail. Bean is a key concept of the Spring framework. As such, understanding this notion is crucial to get the hang of the framework and to use it in an effective way. In Spring, the objects that form the backbone of the application and that are managed by the Spring inversion of control container are called beans. A bean is an object that is instantiated, assembled, and otherwise managed by a Spring inversion of control container. Within the container itself, bean definitions are represented as bean definition objects, which contain, among other information, the following metadata. A package qualified class name, typically the actual implementation class of the bean being defined. Bean behavioral configuration elements, which state how the bean should behave in the container, scope, lifecycle callbacks, and so forth. References to other beans that are needed for the bean to do its works. These references are also called collaborators or dependencies. Other configuration setting to set in the newly created object, for example, the number of connections to use in a bean that manages a connection pool, or the size limit of the pool. This metadata translates to a set of properties that make up each bean definition. In addition to bean definitions that contain information on how to create a specific bean, the application context implementations also permit the registration of existing objects that are created outside the container by users. The Spring inversion of control container is responsible for instantiating, initializing, and wiring beans. The container also manages the lifecycle of beans. As you can see in the figure, the container instantiates a bean by calling its constructor and then populates its properties. This is followed by several calls to the bean until the bean is in the ready state. Similarly, then the container shuts down the container calls to bean to enable it to perform any required tasks before the bean is destroyed. Spring provides several ways through which you can tap into the bean lifecycle. Aware interfaces. Spring provides several aware interfaces. These are used to access the Spring Framework infrastructure. The aware interfaces are largely used within the framework and rarely used by Spring programmers. Bean Postprocessor. Spring provides the Bean Postprocessor interface that gives you the means to tap into the Spring context lifecycle and interact with beans as they are processed. Spring provides two callback interfaces. Initializing bean declares the afterPropertySet method, which can be used to write the initialization logic. The container calls the method after properties are set. Disposable bean declares the destroy method, which can be used to write any cleanup code. The container calls this method during bean destruction in shutdown. Custom init and destroy method. While declaring bean in XML configuration, you can specify the init method and destroy method attributes in the tag. Both the attributes specify custom methods in the bean class. The method declared in the init method attribute is called after Spring initializes bean properties through setter or constructor arguments. You can use this method to validate the injected properties or perform any other tasks. Spring calls the method declared into the destroy method attribute just before the bean is destroyed. The Spring's implementation of inversion of control container, as noted in the previous video, is based on dependency injection. The basic principle behind dependency injection is that objects define their dependencies only through constructor arguments, arguments to a factory method, or properties which are set on the object instance after it has been constructed or returned from a factory method. Then it's a job of a container to actually inject those dependencies when it creates the bean. This is fundamentally the inverse, hence the name inversion of control. Let's see how it works with a simple example. Assume we have declaration of class company. This class needs a collaborator or the address. Normally, we create objects with their classes constructors. There is nothing wrong with this approach. But would it be nice to manage their dependencies in a better way? Imagine an application with dozens or even hundreds of classes. Sometimes we want to share a single instance of the class across the whole application. Other times we need a separate object for each use case, and so on. Managing such a number of objects is nothing short of a nightmare. This is where inversion of control comes to the rescue. Instead of constructing dependencies by itself, an object can retrieve its dependencies from an inversion of control container. All we need to do is to provide the container with appropriate configuration metadata. First off, we need to declare the company class with the component annotation, and write configuration class supplying bean metadata to an inversion of control container. The configuration class produces a bean of type address. It also carries the component scan annotation, which instructs the container to look for beans in the package containing the company class. When a Spring inversion of control container constructs objects of those types, all the objects are called Spring beans as they are managed by the inversion of control container. Since we defined beans in a configuration class, we'll need an instance of the annotation config application context class to build up a container. As we already know, the Spring's implementation of inversion of control container supports several types of dependency injection. Constructor-based dependency injection is realized by invoking a constructor with a number of arguments, each representing a collaborator. Additionally, calling a static factory method with specific arguments to construct the bean can be considered almost equivalent, and the rest of this text will consider arguments to a constructor and arguments to a static factory method similarly. Setter-based dependency injection is realized by calling setter methods on your beans after invoking a no-argument constructor or no-argument static factory method to instantiate your bean. Constructor-based and setter-based types of injection can be combined for the same bean. The Spring documentation recommends using constructor-based injection for mandatory dependencies and setter-based injection for optional ones. In case of field-based DI, we can inject the dependencies by marking them with an auto-wired annotation. While constructing the field DI object, if there is no constructor or setter method to inject the demo bean, the container will use a reflection to inject demo bean into field DI. This approach might look simpler and cleaner, but is not recommended to use because it has a few drawbacks, such as this method uses reflection to inject the dependencies, which is costlier than a constructor-based or setter-based injection. It's really easy to keep adding multiple dependencies using this approach. If you were using constructor injection, having multiple arguments would have made us think that the class does more than one thing, which can violate the single responsibility principle. Frequently, we need to read external resources into our Spring application. Examples of external resources are text files, XML files, properties files, and image files. These resources may be present at different locations. For example, in the file system, class path, or URL. Usually, we have to use different APIs for loading resources from different locations. To handle stack tasks, Spring provides the resource and the resource loader interfaces. Resource is an interface in Spring to represent an external resource. To get resource methods of resource loader decides the resource implementation to use. This is determined by the resource path. As you can see, the resource interface extends the input stream source interface. Some of the important methods of the resource interface are: get input stream, locates and opens the resource. It returns an input stream for reading from the resource. Exists turns a boolean indicating whether this resource actually exists in a physical form. Is open returns a boolean indicating whether this resource represents a handle with an open stream. If true, the input stream must be read once only and then closed to avoid resource leaks. It will typically be false for resource implementations, with the exception of input stream resource. Get description returns a description for this resource. The description can be used for error output than working with the resource. The description is often the fully qualified file name or the actual URL of the resource. Spring provides several implementations for the resource interface. A URL resource represents a resource loaded from a URL. Class path resource represents a resource loaded from the class path. A file system resource represents a resource loaded from the file system. Servlet context resource. This implementation is for servlet context resources. These interpret relative paths within the relevant web application's root directory. Input stream resource represents an input stream resource. Bytary resource represents a bytary resource. We can specify different prefixes for creating path to load resources from different locations. Class path prefix using for load resource from the class path. File prefix using for load external files from file system. HTTP prefix using for load resources from any URL. If we omit the prefix, then the location from which the resource load will be performed which depends on the underlying application context. Now let's see how to load resource using resource loader. First, we need to define the class resource loader service. It has the show resource data using file path method, which contains the getResource method to load a text file from a path provided and print it line by line to console. Next, we need to write the main method. With the help of the Spring application context, we get the resource loader service object and call the show resource data using file path using this object. All the work on defining the resource type and loading is done by Spring. Model View Controller, usually known as MVC, is a software design pattern commonly used for developing user interfaces that divides the related program logic into three interconnected elements. This is done to separate internal representation of information from the ways information is presented to and accepted from the user. This kind of pattern is used for designing the layout of the page. Three important MVC the components are: model, the central component of the pattern. It's the application's dynamic data structure independent of the user interface. It directly manages the data, logic, and rules of the application. View, any representation of information such as a chart, diagram, or table. Multiple views of the same information are possible, such as a bar chart for management and a toolbar view for accountants. Controller accepts input and converts it to commands for the model or view. In addition to dividing the application into these components, the model view controller design defines the interactions between them. The model is responsible for managing the data of the application. It receives user input from the controller. The view means the representation of the model in a particular format. The controller responds to the user input and performs interactions on the data model objects. The controller receives the input, optionally validates it, and then passes the input to the model. Let's assume you go to a restaurant. You will not go to the kitchen and prepare food, which you can surely do at your home. Instead, you just go there and wait for the waiter to come on. Now the waiter comes to you and you just order the food. The waiter doesn't know who you are and what you want. He just written down the detail of your food order. Then the waiter moves to the kitchen. In the kitchen, the waiter not prepare your food. The cook prepares your food. The waiter is given your order to him along with your table number. Cook then prepared food for you. He uses ingredients to cook the food. Let's assume that you order a vegetable sandwich. Then he needs bread, tomato, potato, capsicum, onion, beet, cheese, etc., which he sources from the refrigerator. Cook final hand order food to the waiter. Now it's the job of the waiter to move this food outside the kitchen. Now waiter knows which food you have ordered and how they are served. In this case, view is you, waiter is controller, cook is model, refrigerator is data. Car-driven mechanism is another example of the MVC model. Every car consists of the three main parts. View is user interface, gear level, panels, steering wheel, brake, and etc. Controller is mechanism, engine. Model is storage, petrol or diesel tank. Car runs from engine, take fuel from storage, but it runs only using mentioned user interface devices. Spring Web MVC is the original web framework built on the Servlet API and has been included in the Spring framework from the very beginning. The formal name Spring Web MVC comes from the name of its source model, Spring Web MVC, but it's more commonly known as Spring MVC. The Spring Web MVC framework provides model view controller architecture. The model encapsulates the application data, and in general, they will consist of POGO. The view is responsible for rendering the model data, and in general, it generates HTML output that the client's browser can interpret. The controller is responsible for processing user requests and building an appropriate model and passes it to the view for rendering. In this video, we'll focus on the core concept in Spring MVC controllers. The dispatcher servlet delegates the request to controllers to perform its specific functionality. How does dispatcher servlet know which request needs to be passed to which controller? It uses the request mapping to find out the mapping of a request URL to different controllers. The controller annotation indicates that a particular class acts as a controller. Let's look at the first example. You can easily identify the controller by the controller annotation. This annotation can be applied on classes only. The first use of request mapping indicates that all processing methods on this controller refer to the path hello. The following request mapping method, request method get, annotation is used to declare the print hello method as the default controller service method for handling at HTTP GET request. We can define another method to handle any POST requests for the same URL. We can also write the above controller in a different form, where we can add additional attributes to request mapping like this. The value attribute specifies the URL to which the handler method is mapped, and the method attribute specifies the service method to handle the HTTP GET request. There are some important points regarding the controller defined above. You will define the necessary business logic inside the service method. You can call another method within this method as per requirement. Based on the defined business logic, you will create model in this method. You can set various attributes on the model, and these attributes will be available to the view to represent the result. This example creates a model with the attribute message. A specific service method can return a string that contains the name of the view that will be used to render the model. This example returns hello as the name of the logical view. Model. Model is a central component of the pattern. It's the application's dynamic data structure independent of the user interface. It directly manages the data, logic, and rules of the application. After business logic is processed, a handler method should return a view, which is then resolved by the Spring's dispatcher servlet. Spring allows us to return either a string or a model and view object from the handler method. In the following example, the handler method returns a string and represents a view named login form. That's the simplest way of returning a view name. But if you want to send additional data to the view, you must return a model and view object. As you can see, this handler method returns a model and view object that holds the view name user list and a collection of user objects, which can be used in the view. Spring is also very flexible, as you can declare the model and view object as a parameter of the handler method instead of creating a new one. In an application that follows the MVC architecture, the controller should pass data into the model, which is then used in the view. As we see in the previous example, the addObject method of the model and view class is for putting an object to the model in form of name-value pair. Again, Spring is very flexible. You can declare a parameter of type map in the handler method. Spring uses this map to store objects for the model. This is even simpler than using the model and view object. Depending on your taste, you can use either map or model and view object. In case you want to redirect the user to another URL, if a condition is met, just append redirect before the URL. In the above code, the user will be redirected to the login URL if it's not logged in. Spring makes it easier to handle form submission by providing the model attribute annotation for bidding form fields to a form baking object, and the business result interface for validating form fields. The following code snippet shows a typical handler method that is responsible for handling and validating form data. In this video, we will talk about the views responsible for displaying model data. In Spring MVC, our own controller method doesn't directly render the result using response to output to the browser. The method returns model and view, or even a view name of type string. How does Spring MVC fill the model data in the view? If the controller can understand the view through the logical view name, how does Spring MVC determine which view implementation to use to render the model? Spring does that via the view resolver, which enable you to render models in the browser without tying the implementation to a specific view technology. Let's take a look at the request lifecycle diagram. First, the dispatcher servlet receives a request, then it looks at its setting to understand which controller to use in the figure handler mapping. After receiving the name of the controller, the request is sent to it. In the controller, the request is processed and the model and view is sent back. The model is the data itself, the view is how to display this data. Dispatcher servlet, based on the received model and view, looks for which view to use, view resolver, and receives the name of the view in the response. The data, model, is passed to the view and back, if necessary. The response from the view is sent. Spring MVC defines the view resolver and view interfaces that let you render models in a browser without tying you to a specific view technology. View resolver provides a mapping between the view names and actual views. View addresses the preparation of data before handing over to a specific view technology. Spring MVC supports an impressive set of view technologies. You can use any of these after adding the right Maven dependencies in your project. Spring provides view resolvers out of the box for most of the view technologies. Here is a list of the other view technologies supported by Spring MVC. In the following sections, you are going to go over more traditional technologies like Java Server Pages, as well as the main template engines that can be used with the Spring: ThemeLeaf, Groovy, FreeMaker, Jade. GSP is one of the most popular view technologies for Java applications, and it's supported by Spring out of the box. For rendering JSP files, a commonly used type of view resolver bin is internal resource view resolver. ThemeLeaf is a Java template engine which can process HTML, XML, text, JavaScript, or CSS files. Unlike other template engines, ThemeLeaf allows using templates as prototypes, meaning they can be viewed as static files. FreeMaker is a Java-based template engine built by the Apache Software Foundation. It can be used by generate web pages, but also source code, XML files, configuration files, emails, and other text-based formats. The generation is done based on template files written using the free marker template language. Spring MVC views can also be generated using the Groovy markup templates engine. This engine is based on a builder syntax and can be used by generating any text format. Jade4G is the Java implementation of the pack template engine, originally known as Jade, for JavaScript. Jade4G templates can be used for generating HTML files. Besides the template engines described so far, there are quite a few more available which may be used. GMStage is a template engine which can be easily integrated into a Spring Boot application by using the Spring Boot starter Mustache dependency. Pebble contains support for Spring and Spring Boot within its libraries. Other templates and libraries, such as Handlebars or React, running on top of the GSR 223 script engine, such as Nashorn, can also be used. This is a simple Spring MVC tutorial showing how to set up a Spring MVC project with a Java-based configuration. What is Spring MVC? As the name suggests, it's a model of the Spring framework dealing with the Model View Controller or MVC pattern. It combines all the advantages of the MVC pattern with the convenience of Spring. Spring implements MVC with the front controller pattern using its dispatcher servlet. In a nutshell, the dispatcher servlet acts as the main controller to route requests to their intended destination. Model is nothing but the data of our application, and the view is represented by any of the various template engines. We'll look at JSPs in our example in a while. To enable Spring MVC support through a Java configuration class, all we have to do is add the enable view MVC annotation. This will set up the basic support we need for an MVC project, such as registration controllers and mappings, type converters, validation support, message converters, and exception handling. If we want to customize this configuration, we need to implement the Web MVC configurer interface. In this example, we've registered a view resolver bean that will return JSP views from the web inf view directory. Very important here is that we can register view controllers that create a direct mapping between the URL and the view name using the view controller registry. This way, there is no need for any controller between the two. If we want to also define and scan controllers classes, we can add the component scan annotation with a package that contains the controllers. To bootstrap an application that loads this configuration, we also need an initializer class. Let's have a look at an example of a basic controller, and the corresponding JSP resource is the sample JSP file. The JSP-based view files are located under the web.inf folder of the project, so they are only accessible to the Spring infrastructure and not by direct URL access. Controller. In this video, I'm going to share with you some of the fundamental techniques and best practices for writing a controller class with the Spring MVC framework. Typically, in Spring MVC, we write a controller class to handle requests coming from the client. Then the controller invokes a business class to process business-related tasks, and then redirects the client to a logical view name, which is resolved by Spring's dispatcher servlet, in order to render results or output. That completes a round trip of the typical request-response cycle. This is the simplest way to create a controller class that can handle one or multiple requests, just by annotating a class with the controller stereotype. As you can see, the visitHome method handles requests coming to the application's context path by redirecting to the view named home. Note, the controller stereotype can only be used when annotation-driven is enabled in Spring's configuration file. When annotation-driven is enabled, the Spring container automatically scans for classes under the package specified in the following statement. The classes annotated by the controller annotation are configured as controllers. This is most preferable because of its simplicity. There is no need to declare beans for controllers in the configuration file. Note, by using the controller annotation, you can have a multi-actions controller class that is able to serve multiple different requests. As you can see in the above controller class, there are three handlers methods that process three different requests: list user, save user, and delete user, respectively. Another and maybe classic way of creating a controller in Spring MVC is having a class implement the controller interface. The implementing class must override the handler request method, which will be invoked by the Spring dispatcher servlet when a matching request comes in. The request URL pattern handled by this controller and defined in the Spring's context configuration file as follows: However, a drawback of this approach is that a controller class can't handle multiple request URLs. If you want to easily control the supported HTTP methods, session, and context caching, having your controller class extended the abstract controller class is ideal. This creates a single action controller with configuration regarding the supported methods, session, and caching, which can then be specified in the bean declaration of the controller. This configuration indicates that only the post method is supported by this controller's handled method. Spring MVC also offers several controller classes designed for specific purposes, including abstract URL view controller, multi-action controller, parameterizable view controller, servlet forwarding controller, servlet wrapping controller, URL file name view controller. Spring also makes it easier to handle file upload within a handler method by automatically binding upload data to an array of Commons multiple file objects. Spring uses Apache Commons file upload as the underlying multi-part resolver. A controller should delegate the processing of business logic to relevant business classes. For this purpose, you can use the auto-wired annotation to let Spring automatically inject the actual implementation of a business class to the controller. Consider the following code snipped of the controller class. Here, all business logic related to user management is provided by an implementation of the user DAO interface. By using the auto-wired annotation, the handler methods can delegate tasks to the business class. In some cases, you need to directly access the HTTP servlet request or HTTP servlet response objects within a handler method. By the flexibility of Spring, just add a relevant parameter to the handler method. Spring detects and automatically injects the HTTP servlet request and HTTP servlet response objects into the method. Then you can access the request and response, such as getting input stream, output stream, or returning a specific HTTP code. Finally, there are two good practices you should follow when designing and coding controllers in Spring MVC. A controller class should not execute business logic. Instead, it should delegate business processing to relevant business classes. This keeps the controller focusing on its designed responsibility is to control workflows of the application. Create each separate controller for each business domain. For example, user controller for controlling workflow of the user management, order controller for controlling workflow of order processing, and etc. Java Persistence API, JPA, the Java Object Relational Mapping, ORM, standard for storing, accessing, and managing Java objects in a relational database. In this specification, the Java Persistence API is concerned with persistence, which loosely means any mechanism by which Java objects outlive the application process that created them. Not all Java objects need to be persisted, but most applications persist key business objects. The JPA specification lets you define which objects should be persisted and how those objects should be persisted in your Java applications. By itself, JPA is not a tool or framework. Rather, it defines a set of concepts that can be implemented by any tool or framework. While JPA's Object Relational Mapping, ORM model, was originally based on Hibernate, it has since evolved. Likewise, while JPA was originally intended for use with relational SQL databases, some JPA implementations have been extended for use with NoSQL data stores. Because of their intertwined history, Hibernate and JPA are frequently conflated. However, like the Java servlet specification, JPA has spawned many compatible tools and frameworks. Hibernate is just one of them. Developed and released in early 2002, Hibernate is an ORM library for Java. Hibernate was created as an alternative to entity beans for persistence. The framework was so popular and so needed at the time that many of its ideas were adopted and codified in the first GPA specification. Today, Hibernate ORM is one of the most mature GPA implementations and still a popular option for ORM in Java. Additionally, Hibernate's family of tools has expanded to include popular tools like Hibernate Search, Hibernate Validator, and Hibernate OGM, which supports domain model persistence for NoSQL. While they differ in execution, every GPA implementation provides some kind of ORM layer. Object relational mapping is a task one that developers have good reason to avoid doing manually. A framework like Hibernate ORM or Eclipse Link codifies that task into a library or framework, an ORM layer. As part of the application architecture, the ORM layer is responsible for managing the conversion of software objects to interact with the tables and columns in a relational database. In Java, the ORM layer converts Java classes and objects so that they can be stored and managed in a relational database. By default, the name of the object being persisted becomes the name of the table, and fields become columns. Once the table is set up, each table row corresponds to an object in the application. Object mapping is configurable, but defaults tend to work well. From a programming perspective, the ORM layer is an adapter layer. It adapts the language of object graphs to the language of SQL and relational tables. The ORM layer allows object-oriented developers to build software that persists data without ever leaving the object-oriented paradigm. When you use GPA, you create a map from the data store to your application's data model objects. Instead of defining how objects are saved and retrieved, you define the mapping between objects and your database, then invoke GPA to persist them. If you are using a relational database, much of the actual connection between your application code and the database will then be handled by JDBC, the Java Database Connectivity API. As a specification, GPA provides metadata annotations, which you use to define the mapping between objects and the database. Each GPA implementation provides its own engine for GPA annotations. The GPA spec also provides the persistence manager or entity manager, which are the key points of contact with the GPA system, wherein the business logic code tells the system what to do with the mapped objects. To make all of these more concrete, consider a simple data class for modeling a musician. The musician class is used to hold data. It can contain primitive data such as the name field. It can also hold relations to other classes such as main instrument and performances. A musician's reason for being is to contain data. This type of class is sometimes known as a DTO or data transfer object. DTOs are a common feature of software development. While they hold many kinds of data, they don't contain any business logic. Persistent data objects is a ubiquitous challenge in software development. One way to save an instance of the musician class to a relational database would be to use the JDBC library. JDBC is a layer of abstraction that lets an application issue SQL commands without thinking about the underlying database implementation. The code is fairly self-documenting. The George Harrison object could come from anywhere and has its ID and name fields set. The fields on the object are then used to supply the values of an SQL insert statement. While JDBC allows the control that comes with manual configuration, it's cumbersome compared to GPA. In order to modify the database, you first need to create an SQL query that maps from your Java object to the tables in a relational database. You then have to modify the SQL whenever an object signature change. With GDBC, maintaining the SQL becomes a task in itself. Here we replace the manual SQL from previous code fragment with a single line session save, which instructs GPA to persist the object. From then on, the SQL conversion is handled by the framework, so you never have to leave the object-oriented paradigm. In the previous video, we looked at an example of saving an object using GPA. The magic is the result or the configuration, which is created using GPA annotations. Developers use annotations to inform GPA which objects should be persisted and how they should be persisted. In order to define an entity, you must create a class that is annotated with the entity annotation. The entity annotation is a marker annotation, which is used to discover persistent entities. By default, this entity will be mapped to the musician table, as determined by the given class name. If you wanted to map this entity to another table, you could use the table annotation to do that. Here's how you would map the musician class to a composer table. Additionally, you could add the schema to the table annotation. With the entity map to a table, your next task is to define its fields. Fields are defined as member variable in the class, with the name of each field being mapped to a column name in the table. You can override this default mapping by using the column annotation. In this example, you've accepted the default mapping for the name attribute by specified a custom mapping for the main style attribute. The name attribute will be mapped to the name column, but the main style attribute will be mapped to the main style column. The column annotation allows us to define additional properties of the field or column, including length, whether it's nullable, whether it must be unique, its precision and scale, whether it's insertable and updatable, and so forth. In GPA, the primary key is the field used to uniquely identify each object in the database. The primary key is useful for referencing and relating objects to other entities. Whenever you store an object in a table, you will also specify the field to use as its primary key. The most straightforward way to define an identifier is by using the ID annotation. Simple IDs are mapped using ID notation to a single property of one of these types, Java primitive and primitive wrapper types, string, date, big decimal, big integer. If we want the primary key value to be generated automatically for us, we can add the generated value annotation. This can use four generation types: auto, identity, sequence, table. If we don't specify a value explicitly, the generation type defaults to auto. If we are using the default generation type, the persistence provider will determine values based on the type of the primary key attribute. This type can be numerical or UUID. For numeric values, the generation is based on a sequence or table generator, while UUID values will use the UUID generator feature introduced in Hibernate 5. The identity strategy also generates an automatic value during commit for every new entity object. The difference is that a separate identity generator is managed per type key hierarchy, so generated values are unique only per type key hierarchy. To use a sequence-based ID, Hibernate provides the sequence style generator class. This generator uses sequences if they are supported by our database and switches to table generation if they aren't. To customize the sequence name, we can use the generic generator annotation with a sequence style generator strategy. Sequence is the generation type recommended by the Hibernate documentation. The generated values are unique per sequence. If you don't specify a sequence name, Hibernate will reuse the same Hibernate sequence for different types. The table generator annotation uses an underlying database table that holds segments of identifier generation values. We can see that other attributes such as the PK column name or value column name can also be customized. The disadvantage of this method is that it doesn't scale well and can negatively affect performance. Besides the simple identifiers we've seen so far, Hibernate also allows us to define composite identifiers. A composite ID is represented by a primary key class with one or more persistent attributes. The primary key class must fulfill several conditions. It should be defined using embedded ID or ID class annotations. It should be public, serializable, and have a public no-R constructor. It should implement equals and hash code methods. The class's attributes can be basic, composite, or many-to-one, while avoiding collections, and one-to-one attributes. A composite primary key consists of multiple primary key fields. Each primary key field must be one of the supported types. When an entity has multiple primary key fields, GPA requires defining a special ID class that is attached to the entity class using the ID class annotation. The ID class reflects the primary key fields, and its object can represent primary key values. An alternate way to represent a composite primary key is to use an embeddable class. The primary key fields are defined in an embeddable class. The entity contains a single primary key field that is annotated with embedded ID and contains an instance of that embeddable class. When using this form, a separate ID class is not defined because the embeddable class itself can represent complete primary key values. In this video, we are going to take a look at how to work with a one-to-one relationship between entities in Spring. When a row in a table is related to only one row in another table and vice versa, we say that is a one-to-one relationship. This relationship can be created using primary key unique foreign key constraints. For example, a musician can only have one biography, and also biography can only represent one musician. Let's see how annotate it appropriately in the musician class. Note that we place the one-to-one annotation on the related entity field biography. Also, we need to place the join column annotation to configure the name of the column in the users table that maps to the primary key in the biography table. If we don't provide a name, then Hibernate will follow some rules to select a default one. Finally, note in the next entity that we won't use the join column annotation there. This is because we only need it on the owning side of the foreign key relationship. Simply put, whoever owns the foreign key columns get the join column annotation. The biography entity turns out a bit simpler. We also need to place the one-to-one annotation here too. That's because this is a bidirectional relationship. The biography side of the relationship is called the non-owning side. Another way to create a one-to-one relationship is to share primary key. In this strategy, instead of creating a new column biography ID, we'll mark the primary key column musician ID of the biography table as a foreign key to the musician table. We've optimized the storage space by utilizing the fact that these entities have a one-to-one relationship between them. Notice that our definitions change only slightly. Maps ID annotation tells Hibernate to use the ID column of address as both primary key and foreign key. Also notice that the ID column of the biography entity no longer uses the generated value annotation. The map by attribute for one-to-one annotation is now moved to the musician class since the foreign key is now present in the biography table. In this video, we learn how to make a one-to-many database relationship. One-to-many mapping means that one row in a table is mapped to multiple rows in another table. Let's look at the entity relationship diagram to see a one-to-many association. For this example, we'll have a musician table for each musician and another table for each performance. One musician can have many performances, so here we have a one-to-many mapping. The way this works at the database level is we have an ID as a primary key in the musician table and also a musician ID as a foreign key in performance table. The way we did it in code is with the one-to-many annotation. In the code, we will use one-to-many and many-to-one annotations. Note that the one-to-many annotation is used to define the property in performance class that will be used to map the mapped by variable. That's why we have a property named musician in the performance class. We also add a reference to musician in performance using many-to-one, making this a bidirectional relationship. Bidirectional means that we are able to access performance from musician and also musician from performance. The mapped by property is what we use to tell Hibernate which variable we are using to represent the parent class in our child class. Join column annotation references the mapped column. Now, if musician referenced performances, but performances didn't in turn reference musician, our relationship would be unidirectional. The objects would also have a natural consistency. In our case, though, the relationship is bidirectional, bringing in the possibility of inconsistency. Let's imagine a situation where a developer wants to add performance 1 to musician 1 and performance 2 to musician 2, but makes a mistake so that the references between musician 2 and performance 2 become inconsistent. As shown, performance 2 references musician 2, whereas musician 2 doesn't reference performance 2, and that's bad. GPA resolved this ambiguity using the idea of an owning side of the relationship. References belonging to the owning side take precedence and are saved to the database. As written in GPA specification, it's a good practice to mark many-to-one side as the owning side. In other words, performance would be the owning side and musician the inverse side, which is exactly that we did earlier. We achieve this by including the mapped by attribute in the musician class. We mark it as the inverse side. At the same time, we also annotate the performance musician field with many-to-one, making performance the owning side. In our example, performance to reference is more important and will save performance to reference to the database. It's also possible to mark the one-to-many side as the owning side and many-to-one side as the inverse side, although it's not a recommended practice. In this video, we will discuss ways to work with many-to-many relationships using GPA. A relationship is a connection between two types of entities. In case of many-to-many relationship, both sides can relate to multiple instances of the other side. Note that it's possible for entity types to be in a relationship with themselves. For example, when we model family trees, every node is a person. So, if we talk about the parent-child relationship, both participants will be a person. However, it doesn't make such a difference whether we talk about a relationship between single or multiple entity types, since it's easier to think about relationships between two different entity types. We'll use that to illustrate our cases. For example, a musician may live in different cities throughout his life. Accordingly, many musicians can live in the city. As we know, in relational databases, we can create relationships with foreign keys. Since both sides should be able to reference the other, we need to create a separate table to hold the foreign keys. Such a table is called a join table, city of residence in our example. Note that in a join table, the combination of the foreign keys will be its composite primary key. Modeling a many-to-many relationship is easy. We should include a collection in both classes, which contains the elements of the others. Also, we should configure the relationship type. Hence, we mark the collections with many-to-many annotations. The owner side is where we configure the relationship, which for this example will pick the musician class. We can do this with the join table annotation in the musician class. We provide the name of the join table, city of residence, and the foreign keys with the join column annotations. The join column attribute will connect to the owner side of the relationship, and the inverse join column to the other side. Note that using join table or even join column isn't required. GPL will generate the table and column names for us. However, the strategy GPA uses won't always match the naming conventions we use, hence the possibility to configure table and column names. On the target side, we only have to provide the name of the field, which maps the relationship. Therefore, we set the mapped by attribute of the many-to-many annotation in the city class. Note that since a many-to-many relationship doesn't have an owner side in the database, we could configure the join table in the city class and reference it from the musician class. Suppose we want to add information about how many years musicians have lived in each city. Therefore, it's also a many-to-many relationship. Where can we store this information? We can't put it in the musician entity since a musician can live different years in different cities. Similarly, storing it in the city entity wouldn't be a good solution either. This is a situation when the relationship itself has an attribute. We can model it almost the same way we did with the simple many-to-many relationship. The only difference is we attach a new attribute to the join table. The implementation of the simple many-to-many relationship was rather straightforward. The only problem is that we cannot add a property to a relationship that way, because we connected the entities directly. Therefore, we had no way to add a property to the relationship itself. Since we map DB attributes to class fields in GPA, we need to create a new entity class for the relationship. Of course, every GPA entity needs a primary key. Because our primary key is a composite key, we have to create a new class, which will hold different parts of the key. We discussed how to create a composite primary key in a previous video. Here we just note that there are some key requirements, which a composite key class has to fulfill. We have to mark it with embeddable annotation. It has to implement a serializable interface. We need to provide an implementation of the hash code and equals methods. None of the fields can be an entity themselves. Using this composite key class, we can create the entity class, which model the join table. This code is very similar to a regular entity implementation. However, we have some key differences. We used embedded ID to mark the primary key, which is an instance of the city year key class. We marked the student and course fields with maps ID. Maps ID means that we tie those fields to a part of the key, and they are the foreign keys of the many-to-one relationship. We need it because, as we mentioned above, in the composite key we can't have entities. After this, we can configure the inverse references in the musician and city entities like before. We configured the relationships to the musician and city classes as many-to-one. We could do this because with the new entity we structurally decomposed the many-to-many relationship to two many-to-one relationships. Moreover, this solution has an additional feature. The simple many-to-many solution creates a relationship between two entities. Therefore, we cannot expand the relationship to more entities. However, in this solution, we don't have these limits. We can model relationships between any number of entity types. When we are building APIs, we want our models to provide 4 basic types of functionality. The model must be able to create, read, update, and delete resources. A model should have the ability to perform at most these 4 functions in order to be complete. The CRUD paradigm is common in constructing web applications because it provides a memorable framework for reminding developers of how to construct full, usable models. Create. This would consist of a function which we would call when a new object is being added to the catalog. The program calling the function would supply the values for fields. After this function is called, there should be a new entry in the catalog corresponding to the new object. Additionally, the new entry is assigned a unique ID, which can be used to access this resource later. Read. This would consist of a function which would be called to see all the objects currently in the catalog. This function call wouldn't alter the object in the catalog. It would simply retrieve the resource and display the results. This object wouldn't be modified, only retrieved. Update. This should be a function to call when information about the object must be changed. The program calling the function will supply the new values for object fields. After the function call, the corresponding entry in the object resource would contain the new fields supplied. Delete. There should be a function to call to remove an object from the catalog. The program calling the function would supply one or more field values to identify the object, and then this object would be removed from the catalog. After this function is called, the catalog should contain all of the objects it had before, except for this one just deleted. A transaction simply represents a unit of work. In such case, if one step fails, the whole transaction fails, which is termed as atomicity. Hibernate framework has transaction interface that defines the unit of work. It maintains abstraction from the transaction implementation GTA JDBC. A transaction is associated with a session and instantiated by calling session begin transaction. A transaction can be described by ACID properties: atomicity, consistency, isolation, and durability. Begin starts a new transaction. Commit ends the unit of work unless we are in flash mode, never. Rollback forces this transaction to roll back. Set timeout. It sets a transaction timeout for any transaction started by a subsequent call to begin on this instance. Is alive. Checks if the transaction is still alive. Register synchronization. Registers a user synchronization callback for this transaction. Was committed. Checks if the transaction is committed successfully. Was rolled back. Checks if the transaction is rolled back successfully. The create method is intended for adding a new entity instance to the database table. This implementation wraps all operations in transaction scope. For complex objects that allow to add records into multiple tables in atomic way. If we occur error in one of operation, all already inserted data will be rolled back. Another way is to use Spring Data. Spring Data is Spring-based programming module for data access. It reduces the amount of code needed for working with databases and data stores. It consists of several modules. The Spring Data GPI simplifies the development of Spring applications that use GPA technology. With Spring Data, we define a repository interface for each domain entity in the application. A repository contains methods for performing CRUD operations, sorting and pagination data. Repository is a marker notation which indicates that the underlying interface is a repository. A repository is created by extending specific repository interfaces, such as CRUD repository, paging and sourcing repository, or GPA repository. Spring Data has advanced integration with the Spring MVC controllers and provides dynamic query derivation from repository method names. Service classes are decorated with the service annotation in Spring. The musician repository extends from the CRUD repository. It provides the type of entity and its primary key. If you don't know the identifier of the objects you are looking for, you need a query. Hibernate supports an easy-to-use but powerful object-oriented query language, HQL. For programmatic query creation, Hibernate supports a sophisticated criteria and example query feature, QBC and QBE. You can also express your query in the native SQL of your database, with optional support from Hibernate for result set conversion into objects. Sometimes we need to get all data from table. In this case, we can query database and represent result as Java list object. But if table contains many rows, they all cannot fit in memory. Above example is useful only for tables contain few records. If you need to get part of table or only one row, you can execute query using HQL or SQL. HQL and native SQL queries are represented with an instance of ORG Hibernate query. This interface offers methods for parameter binding, result set handling, and for the execution of the actual query. You always obtain a query using the current session. A query is usually executed by invoking list. The result of the query will be loaded completely into a collection in memory. Entity instances retrieved by a query are in a persistent state. Occasionally, you might be able to achieve better performance by executing the query using the iterate method. This will usually be the case if you expect that the actual entity instances returned by the query will already be in the session or second-level cache. If they are not already cached, iterate will be slower than list and might require many database hits for a simple query, usually one for the initial select, which only returns identifiers, and n additional selects to initialize the actual instances. In case when you want to find specific record, you can use find by ID method of CRUD repository. Sometimes selection data from the table is not enough. Hibernate allows you to execute more complex queries, for example, select data from multiple joined tables. Sometimes we need to get all data from table. In that case, we can query database and represent result as Java list object. But if table contains many rows, they all cannot fit in memory. Above example is useful only for tables contain few records. Queries can specify a property of a class in the select clause, then can even call SQL aggregation functions. Properties or aggregates are considered scalar results and not entities in a persistent state. Methods on query are provided for binding values to named parameters or JDBC style parameters. Contrary to JDBC, Hibernate numbers parameters from 0. Named parameters are identifiers of the form name in the query string. The advantages of named parameters are as follows. Named parameters are insensitive to the order they occur in the query string. They can occur multiple times in the same query. They are self-documenting. If you need to specify bounds upon your results set, this is the maximum number of rows you want to retrieve or the first row you want to retrieve. You can use methods on the query interface. The findAll method calls repositories findAll method of CRUD repository and retrieves all musicians. We can update an object in Hibernate by calling the update method, provided by the org.hibernate.session. Through the update method is used to update an object. There are two different ways to use update method: without loading an object from the database, loading an object from the database. Usually, if we want to update a record in the database, first of all, we should get that record and manipulate and save it to the database. It's a usual practice of updating the record in the database. But in Hibernate, if we know the record ID, primary key, we can directly update the record in the database without load or getting the record from the database. If we know the record ID, then we can directly create a new object and assign the primary key to it and save using update method. A problem with the approach is we must set all the properties of an object. If we don't set any one of the property, then its default values, null, will be updated in the database. By using this approach, you can update an object with loading the object from the database. We can load the object from the database by calling load or get methods. There are some functionality differences between the load versus get methods in Hibernate. From these two approaches, the current one, Hibernate update with loading an object, is a recommended approach because here we no need to set all the properties. Based on your requirement, we can update the values as we want. After loading object, you can update fields and save it by using the method save of CRUD repository. As a full-featured ORM framework, Hibernate is responsible for lifecycle management of persistent objects, including deleting operation. Objects may be deleted in the following scenarios: deleting a transient instance, deleting a persistent instance, using Hibernate query language. The session delete method allows us to remove a transient instance of the entity with an identifier associated with existing persistent state. A transient instance is the one which doesn't associate with the session. For example, the following statements delete a product whose identifier equals to 10. This way is simple and straightforward because we don't have to load a persistent instance from the data store before deleting it. However, its drawback is that it doesn't remove the associated instances. Even an appropriate cascade type is specified in the class mappings annotations. In this way, we load a persistent instance using the session load class ID method before deleting it. The following code snippet solves the above problem of deleting an object with associated entities. In this way, we use Hibernate query language to delete entities with more flexibility, such as removing products those prices are greater than a specified amount. As you can see, Hibernate issues only one delete query in contrast with the first two approaches in which Hibernate issues a select query first, then to delete. However, this approach doesn't remove associated instances. The delete method calls repository delete by ID method that musicians remove from table musician with a specified ID. REST, or representational state transfer, is a software architectural style that defines a set of constraints to be used to creating web services. Web services that conform to the REST architectural style, called RESTful Web Services, provide interoperability between computer systems on the Internet. RESTful Web Services allow the requesting systems to access and manipulate textual representations of web resources by using a uniform and predefined set of stateless operations. REST is a set of principles that define how web standards such as HTTP and URLs are supposed to be used. All our resources have unique identifiers, URL, which gives us an opportunity to logically formulate our requests and structure URLs available for request universality. You can use the same server response data to return back to XML or JSON for software processing or to wrap in a beautiful design for people to see. Each URL is called a request, while the data sent back to you is called a response. What is an actual request? It's made up for things: the endpoint, the method, the headers, the data or body. The endpoint is the URL you request for and has this structure: root endpoint path. The root endpoint is the starting point of the API we are requesting from. For example, the root endpoint of GitHub's API is http api.github.com. The path determines the resource that is being requested. For example, let's say you want to get a list of repositories by a certain user through GitHub's API. The docs tell you to use the following path to do so: users, username, repos. Any columns on a path denotes a variable. You should replace these values with the actual values of when you send your request. In this case, you should replace username with the actual username of the user you are searching for. One of the most common bad practices done by the REST API developers are to use the verbs for naming the REST endpoints. You must always use nouns instead of using verbs. Use plurals for naming your REST services. This is another hot topic among the REST designers, to choose between plural or singular nouns for naming the services. Query parameters appear in the URL after the question mark. Each parameter key-value pair is then separated with an ampersand. As a best practice, almost all developers are recommending the following way. If you want to sort or filter items, then you should use query parameter. For example, when you try to get a list of the user repositories on GitHub, you could add query parameters to your URL. Here we use sort pushed as query parameter to see the list of recent repositories pushed by the username tutor. REST is a service that implements actual service-oriented architecture, SOA, an architectural pattern in computer software design in which application components provide services to other components via a communication protocol, typically over a network. The most common protocol is HTTP. For HTTP, the action on the data is set using methods. Designing operations on HTTP methods becomes easier when you know the characteristics of all HTTP methods. Safety and idempotent are the two characteristics that has to be determined before using a HTTP method. A HTTP method is considered as safe when invoking that method doesn't change the state of the resource. For example, when you are retrieving a data using the get method, this is safe because this method doesn't update the data to backend. When you get the same response how many times you invoke the same resource, it's known as idempotent. For example, when you try to update a same data to backend, the response will be same for every request made with the same data. Not all the methods are safe or idempotent. Here is the list of methods that can be used for REST API calls and what are the methods safe and idempotent. Get. This method is safe and idempotent. It's always used for retrieving the information and doesn't have any side effects. Post. This method is neither safe nor important. This method is most widely used for creating the resources. Put. This method is idempotent. That is the reason instead post one you can use this method for updating the resources. Avoid using post for updating the resources. Delete. As the name implies, this method is used for deleting the resources, but this method is not idempotent for all the requests. Options. This method is not used for any resource manipulation, but it's useful when client doesn't know the various methods supported for a resource. Using this method, client can retrieve the various representation of the resource. Head. This method used for querying a resource in the server. It's very similar to GET method, but head has to send request and get the response only in the header. As per HTTP specification, this method shouldn't use body for request and response. HTTP defines various status codes for indicating different meaning to the client. Your REST API could effectively use all the available HTTP codes to help the client route their response accordingly. Here is a list of some of the HTTP status codes for reference. 200 awk. This is a response to successful get, put, patch, or delete. This code also be used for a post that doesn't result in a creation. 201 created. This status code is responsible to a post that results in a creation. 204 not content. This is a response to a successful request that won't be returning a body, like a delete request. 304 not modified. Use this status code when HTTP caching headers are in play. 400 bad request. This status code indicates that the request is malformed, such as if the body doesn't parse. 401 unauthorized. Then no or invalid authentication details are provided. Also useful to trigger an auth pop-up if the API is used from a browser. 403 forbidden. When authentication succeeded, but authenticated user doesn't have access to the resource. 404 not found. When a non-existent resource is requested. 405 method not allowed. When an HTTP method is being requested that isn't allowed for the authenticated user. Headers are used to provide information to both the client and server. It can be used for many purposes such as authentication and providing information about the body content. The headers that you will encounter the most during API testing are the following. You may need to set values for these or set assertions against these headers to ensure that they convey the right information and everything works fine in the API. Authorization carries credentials containing the authentication information of the client for the resource being requested. www authenticate. This is sent by the server if it needs a form of authentication before you can respond with the actual resource being requested. Often sent along with the response code of 401, which means unauthorized. Except char set. This is a header which is set with a request and tells the server about which character sets are acceptable by the client. Content type indicates the media type text HTML or text JSON of the response sent to the client by the server. This will help the client in processing the response very correctly. Cache control. This is the cache policy defined by the server for this response. A cached response can be stored by the client and reused till the time defined by the cache control header. The data, sometimes called body or message, contains information you want to be sent to the server and could be used with post, put, or delete requests. JSON, JavaScript object notation, a common format for sending and requesting data through the REST API. The most common way to document REST APIs is to produce documentation that lists the API endpoints and describe the list of operations allowed on each endpoint. There are plenty of tools that allow you to do this in an automated way. Here is some of the tools that may help you to document your REST services. This guide walks you through the process of creating a Hello World RESTful Web Service with Spring. You will build a service that will accept HTTP GET requests. It will respond with a JSON representation of a greeting. Begin the process by thinking about service interactions. The service will handle GET request for greeting, optionally with a name parameter in the query string. The GET request should return a 200 OK response with JSON in the body that represents a greeting. It should resemble the following output. The ID field is a unique identifier for a greeting, and content is the textual representation of the greeting. To model a greeting representation, create a resource representation class. To do so, provide a plain old Java object with fields and accessors for the ID and content data, as the following list shows. In this example, our application uses the JSON library to automatically marshal instances of type greeting into JSON. JSON is included by default by the web starter. In Spring's approach to building RESTful web services, HTTP requests are handled by a controller. These components are identified by the REST controller annotation, and the greeting controller shown in the following listing handles GET requests for greeting by returning a new instance of the greeting class. This controller is concise and simple, but there is plenty going on under the hood. We break it down step by step. The GET mapping annotation ensures that HTTP GET requests to greeting are mapped to the greeting method. There are companion annotations for other HTTP verbs, for example, post mapping for post. There is also a request mapping annotation that they all derive from and can serve as a synonym. Request param binds the value of the query string parameter name into the name parameter of the greeting method. If the name parameter is absent in the request, the default value of word is used. The implementation of the method body creates and returns a new greeting object with ID and content attributes based on the new value from the counter and formats the given name by using the greeting template. A key difference between a traditional MVC controller and the RESTful Web Service controller shown earlier is the way that the HTTP response body is created. Rather than relying on the view technology to perform server-side rendering of the greeting data to HTML, this RESTful Web Service controller populates and returns a greeting object. The object data will be written directly to the HTTP response as JSON. This code uses Spring REST controller annotation, which marks the class as a controller where every method returns a domain object instead of a view. It's shorthand for including both controller and response body. The greeting object must be converted to JSON. Thanks to Spring's HTTP message converter support, you needn't to do this conversion manually. Because JSON2 is on the class path, Spring's mapping JSON2 HTTP message converter is automatically chosen to convert the greeting instance to JSON. In this video, we will discuss some solutions and strategies for handling errors that might appear in your application. Before we start, it might be important to discuss the overall goals of why we do errors handling. When an error occurs, you need to ask yourself a few questions. Why did the error occur? How to recover from the error? How to avoid the error in the future? The goal of error handling is to be able to answer these three questions when an error is encountered. The first question can be answered by providing the user with enough information when the error occurs in order to identify the cause. For example, when the user tries to access a resource which doesn't exist, it would make sense to reply with an HTTP error code 404 not found instead of just 400, bad request, or worse, an HTTP code 500, server error. There are many things that you can do to recover from an error. The strategy that you implement will depend on the error. From which perspective are you handling the error? Are you the developer? Are you a user and your application? Sometimes you can recover instantly from an error and you might need to retry your request later. Sometimes you might have to make changes in your application. Finally, in order to avoid the error in the future, you may need to make some changes in your configuration or implementation. For example, if you see that users are complaining that they are always getting X error when calling Y method in your production environment, you might have to change method Y to satisfy the customer's needs. To enable you or other developers and users of the system to do this, you will need to gather enough information about the error in order to troubleshoot it and fix it. This can be done by logging the error and saving the logs for future analysis. Let's see examples of JSON responses generated in case of error. This is a REST API endpoint for getting information about a bird. Here is an example of JSON returned when an entity isn't found while calling this endpoint with ID equals 2. Here is another example of JSON returned when issuing a post endpoint's bird's call with an invalid value for the bird's mask. As we all know, exception handling is the most important and a crucial thing in the Spring Boot REST APIs, which helps us to perform conditional and unconditional check-ins for our code and handle any kinds of exception in a proper way. Along with its benefits, it also complicates the code and makes the code not easily readable to unknown users. Using try-catch blocks anywhere in your code isn't recommended because they are not able to read the code properly, and also it increases more unwanted lines in your class. So we need to have a common place where we can manage and handle all kinds of exceptions and send the respective error code for the API response depending on the exception types. Spring Boot provides a very powerful annotation called controller advice. This annotation makes our life easier to handle all kinds of exceptions at a central place in your application. We don't need to catch an exception at each method or class separately. Instead, you can just throw the exception from the method and then it will be caught under the central exception handled class annotated by control advice. Any class annotated with control advice will become a controller advice class which will be responsible for handling exceptions. Under this class, we make use of annotations provided as exception handler, model attribute init binder. Exception handling method annotated with exception handler will catch the exception thrown by the declared class, and we can perform various things whenever we come through the related type exceptions. Controller advice constructor comes with some special arguments, which allows you to scan only the related portion of your application and handle only those exceptions through by the respective classes mentioned in the constructor. By default, it will scan and handle all the classes in your application. Some types which we can use to restrict only specific classes to handle exceptions are annotations. Controllers that are annotated with the mentioned annotations will be assisted by the controller advice annotated class and are eligible for exception of those classes. Here, the exception helper annotated by controller advice will catch all the exceptions thrown by the REST controller annotation classes. Back packages. By specifying the packages that we want to scan and handling exceptions for the same. This will only scan, call the mentioned package and handle the exceptions for the same. Assignable types. This argument will make sure to scan and handle the exceptions from the mentioned classes. So by using exception handler and controller advice, we'll be able to define a central point for treating exceptions and wrapping them up in an API error object with better organization than the default Spring Boot error handling mechanism. In this lesson, we will look at how you can get database objects by REST. To do this, remember that we went through in the previous lessons and used the knowledge gained. First, let's create a simple database with two tables, users and their roles. We will fill their roles with migration with two predefined roles, user and administrator. Our object models will be like this. Don't forget to add the GPA repositories of our entities, user repository and user role repository. We will also add a REST controller, user controller, in which we will add a method for getting a list of roles and getting one role by ID. As you can see in the example, we used the pageable parameter in the getRoles method. It is required for pagination and sorting of responses. For everything to work, you need a repository, user role repository, expand from paging and sorting repository. In this tutorial, we will be creating a new user using REST. The only available option to do this is to use the post method. Let's use the custom model from the previous tutorial. In order to create a user, we need to pass the following parameters: email, user role, and name. To do this, we will create a separate requests view that we will execute, then creating a new user. It will look like this. Our next step will be to create the post method in the REST controller, in the bar of which we will transfer the user create request and return the user entity serialized in the JSON. In this method, first of all, we need to find the user's role by ID and then create a user. As you can see, we have used the valid annotation. It's necessary for the properties of our user create request to be validated. We should correct the user create request by specifying in it how the properties should be validated. To do this, we will use the email and not empty annotations. After that, our view on user create will take the final form. In this tutorial, we will update user information using REST. For this, we will use the put method. User and user role models will be used from the previous lessons. First, we need to determine which user properties we want to edit. In our case, this will be the role and name. Our next step will be to create a model that we will send in a user edit request. To do this, create a new user update request model with the following content. As you can see, we immediately used annotations to validate property values. After creating the model, we just need to implement the method in the user controller. First, we will find a user by ID who will come to us as path param, when we will search for user role by ID. If everything went well, then all that remains is to edit the user properties, save it to the database, and return the updated model. We have already learned how to create and update a user. It remains only to add the ability to delete it. In some systems, when deleting, a certain flag for deleting a user is set, but we will delete it from the database. As you can remember in the previous lessons on REST CRUD, in the user controller methods, we accepted a certain data model and returned a certain model. When deleting, we don't need this because we only delete the user by ID, and we will indicate the success of the operation through a special HTTP code 204, not content. This is very important if you want to create a RESTful web service, and the standard HTTP code 200 will not work here. The implementation of the delete method will be pretty straightforward. Its only peculiarity is that we will catch an exception if such a user doesn't exist in the database.